Hello everyone, Ewan from Elixir Experts here. Today I'm going to discuss potential issues using the collapsed as-built method of delay analysis in dispute resolution and why it is potentially used by some parties. As demonstrated in my first video, I highlighted that the collapsed as-built method of delay analysis might prove unreliable in dispute resolution if delays are collapsed out in the wrong order. In effect, the analyst could be collapsing out non-critical delays, giving greater effect to other critical delays. It is also recognised, including in the Society Construction Law's Delay and Disruption Protocol, that a limitation of this method is that it only measures the incremental delay to the critical path, because the completion date will not collapse out further than the next nearest critical path determined from an as-built perspective. This will not necessarily represent the actual or contemporaneous critical path at the time, which could be different if, for example, there were changes to the planned sequences of work at the time. In addition, as the delays are collapsed out, the analysis can be criticised for highlighting a hypothetical situation that never happened, which may lower the confidence that tribunals have in the findings being reliable. In effect, this method is really asking the question, but for the event or events, what would the completion date have been? An analysis using this method may only consider arbitrarily selected delay events, which might mask the effect of delays from one party, so the results favour the party performing the analysis. In other words, the results of such an analysis might be biased and unreliable. Since the collapsed as-built method of delay analysis requires an as-built program, it is less helpful during the project as parties have to wait until the works are complete before conducting the analysis. To this extent, it does not provide an early warning of delay to the project at the time. A further consequence of not identifying the actual or contemporaneous critical path at the time is that the method can struggle to deal with concurrency, where multiple events are causing critical delay to completion at the same time. In other words, it might not effectively differentiate between the various delay events happening concurrently. This might arise where two delays overlap, and because one delay finishes later than the other, it appears on the as-built critical path, at the expense of the other delay which may have been driving completion at the time as part of the contemporaneous critical path. If the works are resequenced or rebaselined during the works, then the collapsed as-built method of delay analysis may not adequately capture changes in the project execution strategy at the time. For example, the method may overlook mitigation or acceleration. This can potentially lead to an inaccurate assessment of the critical path and delay to the project by not taking account of changes in the critical path at the time, since the method only identifies the critical path at the end of the project or after the collapsing out of delays to establish the completion date but for the delays. The method also relies upon accurate as-built data, recording when works were carried out, as flawed or incomplete program data can compromise the reliability of the delay analysis. Assembling an as-built program in appropriate detail is likely to be difficult, complex, and resource-intensive. In addition, it is necessary for logic to be inserted into the as-built program, which is not always a straightforward exercise to model how the works were carried out. It can also be difficult to model delays. Delays can be straightforward to model, where they say relate to discrete periods of time with a clear start and finish date, such as for late design information. However, they may also be more difficult to model, where they say relate to achieving a lower productivity more generally for an activity, which is also being affected by other delays. This can lead to unrepresentative delays being included in the analysis, or possibly some delays being ignored or exaggerated over others. So, why do parties use this method of delay analysis? Firstly, it is recognised in the Society of Construction Law's Delay and Disruption Protocol, 2nd edition, February 2017, as a legitimate method of analysis. If the circumstances are appropriate, with accurate as-built data and no concurrency, it may be a reliable method of delay analysis in dispute resolution. Secondly, it might be mandated by the contract as the method for assessing delay, and as such a party may be obliged to use this method to assess delay. However, it is a retrospective method of analysis that requires the work to have been carried out to show actual critical delays, and so it is of less utilisation whilst the works are being carried out. The collapsed as-built method does not require a baseline programme. This can be particularly advantageous in situations where the baseline does not exist, or alternatively where it is not of suitable granularity to measure delay against. The collapsed as-built method of delay analysis is derived from as-built data, and so on one hand represents what actually happened. This can be persuasive, but the method of analysis still compares to a hypothetical situation that never happened, which, as I noted earlier, may lower the confidence that tribunals have in the findings of the analysis being reliable. However, if the results produced can be verified against other as-built data, this can improve the robustness of the analysis. The method can be performed where program updates either do not exist, are too few, or potentially just unreliable. I would repeat my comment earlier, though, that producing an as-built program with delays from scratch can be resource intensive, requiring significant data and time. It may also be beneficial for one party to use the collapsed as-built method of delay analysis to maximise its commercial position by advancing a position that masks some delays, relying on the as-built critical path, which does not reflect the actual or contemporaneous critical path. There is also a potential for delay events to be arbitrarily selected and to exaggerate their duration. The collapsed as-built method of delay analysis can be stress tested by running what-if scenarios, checking that activities in the model are performed in a reasonable and logical sequence, as well as determining the sensitivity of the findings. In summary, if there is no baseline program, the collapsed as-built method of delay analysis may be the best available method to carry out a delay analysis, and can be reliable in dispute resolution if carried out appropriately. Whereas it is based upon as-built data, it is still a simulation of progress, and the key question that it really answers is, but for the event or events, what would the completion date have been? That's it for now, and have a great day.